So let us discuss what we have did in the previous lecture. So in the previous lecture we have talked about the graphs, definition of graph. So graph is the denoted as G, which is the order pair of V and E, where V is called the vertex set, E is called the edge set. V cannot be empty, E may or may not be empty. Every element of E is assigned two elements of V, and that two elements are called the end point of the vertex E. A member of E is called the edges, a member of V is called the vertices. So this was the definition of graph which we have discussed. Then we have discussed the order of the graph, size of the graph, self loop, parallel edges, a simple graph, multi graph, finite and infinite graphs. And then we have discussed regarding some applications of a graph theory. In that we have discussed the seven bridge problem, problems of finding the shortest path. Then we have discussed about the adjacency matrix, incidence matrix, the degree of the vertex. We have proved certain results that the sum of all the degree is always even. We have discussed the handshaking lemma, which says that there are even number of odd vertices. We have discussed regarding the isolated vertex, pendant vertex, null graph. We have also discussed regarding the isomorphism. Iso means one, so that will be two graph is there, but they are in apparently they are same. So that concept we have discussed. We have also discussed regarding the complete graph, bipartite graph, complete bipartite graph. And then lastly we have discussed a directed graph. It is, in short, it's also known as a digraph. Okay, so directed graph is also another name is a digraph. So all sort of things we have discussed in the previous lecture. In this lecture we'll discuss regarding the graph, paths and the connected graphs. Let's see how much I can cover up with this. So first definition is a subgraph. Okay. So a sub means it is a part of the graph. Let us see G is a graph with the vertex set. The vertex set of G is V of G if I denote, and the edge set I am denoting by E of G. Okay. There is another graph H. H is a graph whose vertex set is V of H, and the edge set, if I denote as E of H, when I can say this H, it's called a subgraph of G if this vertex set of H is a subset of vertex set of G, and edge set of H is a subset of edge set of G. Let us see the example. Let us consider this is a graph. So these are the vertices. There are 8 vertices. So I can say this G is the graph, and if I draw this H here, then I can say that H is a subgraph of G, because either you can pick these 4 vertices, that is here, and then I'm just using this 4 edges. If I can have this graph, let's say this is H1, this is extra edge is here, so this condition is not satisfying there. That is, edge set of H is not a subset of edge set of G, because this is the extra edge we have here. So this H1 is not subgraph of G. So this gives you idea what do you mean by subgraph of a G. Then there is called a proper subgraph. H, it's called a proper subgraph of G. If this vertex set of H is a proper subset of vertex set of G, and edge set of H is a proper subset of edge set of G, then this is known as a proper subset. A proper subset means the V of H is not equal to V of G, and E of H is not equal to V of H. So they are subsets but never equal. So this, I can say this H is a proper subset of G. H1 is not, but if I can say that, if I'm drawing the figure like this, if I can say this is H3, then H3 is not proper subgraph of G. The G is, we have already mentioned here, this is my G. But this H is a proper subgraph of H, because the vertex set is not equal, edge set is also not equal. Here it is edge set, E of H. This is E of H. So this is a definition of proper subgraph. Our next definition is a spanning subgraph. Probably a definition of a span you have learned in your linear algebra course. So here it is the same kind of things is there. A spanning subgraph in which the vertex is the same, vertex set of the graph H and the graph G is the same, then H, it's called a spanning subgraph of G. So a spanning subgraph of G is a subgraph. First of all, it has to be subgraph H with vertex set of H is exactly same as vertex set of G. So I can say this H3 is a spanning subgraph of G. It is not proper subgraph, but it is a spanning subgraph of G. Vertex set has to be same. Then we can say that it is a spanning subgraph. So here I can say that H3 is a spanning subgraph of G. So that is the definition of spanning subgraph. Or there is also one more definition, it's known as the spanning supergraph of G. So I hope that everyone is able to now define what you mean by spanning supergraph. So can somebody try to define a spanning supergraph? Super means bigger graph than the original graph. Is the same. Just a spanning supergraph of G is the supergraph of H. Supergraph means it is something extra. Extra is there. With vertex set is the same. For example, if this is my original graph G, this is the graph G I'm considering. And now what is the supergraph? Sorry, spanning supergraph, it has to be this many vertices has to be there. So there are 8 vertices here. So the 8 vertices has to be there. If I can draw like this, then it is a subgraph, spanning subgraph. And one more edge is already there. And here is also one more edge. If I can add one more edge here, then this is this. If I can say this is H. The vertex set of H is same as a vertex set of G. But one more edge is included here. So that's why this is H is a spanning supergraph of G. So this is the definition of a spanning supergraph. So if I have a graph, simple graph, so what does it mean? What is the definition of a simple graph? It has no loops and no edge, parallel edges. That is known as a simple graph. So can I make a statement that every simple graph with n vertices is a subgraph of complete graph. Kn. Can I make this statement?
Yes, sir.
Because complete graph is a graph in which every edge is connect to every other edge. That is known as a complete graph. Okay, if it has n vertices, whatever the graph you draw, that all of them are the subset, or I can say a subgraph of Kn. That is a complete graph. Okay. Now let us discuss regarding the operation. On a graph. Operation on a graph, like if we have a numbers, two numbers, then we can add them, we can subtract them. Likewise, can we do some operation on this? That means, can we do the union of two graphs? Intersection of a two graphs. How can define an intersection union of a two graphs? Okay, so that is the concept called the operation on a graph. So the first things we are defining the union of a graph. So if you have two graphs, let's say a G1, which is V1 E1, and G2, which will be V2 E2, are two graphs are given to you. And if I want to define now the union of G1 and G2, so let's say there is another G3 is equal to V3 E3 is another graph, and if I want to say that this G3 is the union of this U1 and U2, and it is denoted as G3 equal to G1 union G2. So it is denoted as union if the age set, that is E3, is the union of E1 and U2, E2, and V3 is the union of V1 and V2. That means the age set will be union. You know what do you mean by union? That means either the age is in E1 or it is in E2. The same way, it is the vertex is in V1 or it is in V2. Let's say the example. Suppose this is a graph G1. Another graph I'm saying it is G2 here. This is the graph G2. And if I denote the number, that means a vertex as V1, V2, V3, V4. Here you can see that this V1, V2, V3 are isomorphic to this three vertex. So I am just making as a same index. And this is the another one, that's why I am saying it is V5. And the ages that we have here, let us call this as A age, B, C and D. And you can just see that this A and D is similar here. So that's why I'm saying it is A and D. And this is extra age is there, which is not here. So I'm just saying it is E. Now what will be the union of these two? So according to this, the age set is union and the vertex set will be union. So there are 4 vertices here and 4 vertices are here. So altogether there will be a 5 vertex, that is a union of, because the V1 is here, V1 contains V1, V2, V3, V4. Here V2 contains V1, V2, V3, V5. You know the how to do the SAT union. So the union will contain V1, V2, V3, V4 and V5. So that's why I plotted this. So you can just say that this is V1, this one is V2, V3, V4 and this is V5. Now we have to join them. So according to this, the age set will be making the union. Here the age set is A, B, C, D. Here age set is A, B, D. The union of that one will give you A, B, C, D, E. All this ages plus this age. So this graph is actually G1 union G2 graph. So union of 2 graphs is defined like this. So you can say that this is A, B, C, D and E is there. A same way we can define the intersection of 2 graphs. So the intersection of a 2 graphs, as we have already defined what is G1, what is G2. If I want to say that G4 is a graph, if you want to say that is the intersection of G1 and G2, it's denoted as G1 intersection G2 is the graph which consisting of those vertices and edges that are in both G1 and G2. So G4 is a graph consisting only of those vertices and edges that are in both G1 and G2. That means if I want to draw a intersection of this G1 and G2, so you have to plot all those vertices which are in both. So the V1 is in both, V2 is in both, V3 is in both. So the G4, that is, we have, this is the graph which we have here, because this A and D is a common vertex, so edges, and V1, V2 and V3 are the, so this is the graph which is the intersection of G1 and G2. Then a next definition is a ring sum of two graphs. So I can say G5 is equal to G1 ring sum G2 is a graph consisting of vertex set as V1 union V2 and edge of edge set are neither in G1 or in G2, but not in both. Okay, so you have to see what are the edges which are not in both. So this type of operation you are doing in the set theory, like A minus B. So what you are saying, it is A intersection B complement. So it is in A, all the things which are in A but not in B. So it's likewise this. It is the vertex set is a union. So for example, if I want to plot a ring sum of G1 and G2, then the vertex set is the union of these two. That means the vertex set of this G1 union G2 has 4 vertices will be there and one more 5. So this was your vertices for G1 ring sum G2, and as per this, the edge set are neither in G1 or in G2 but not in both. So all those edges which are not in both, that means you have to subtract the intersection between them. So this edges A and D, you have to subtract from that, and all the remaining edges will be there. So what you will have is this edge, you will have this edge, and this edge, because this edge and this edge are common in both, so that's why it is there. So that's why what we can say, this is the graph which we have. It is the graph which tells you regarding the G1 direct sum, or I can say a ring sum G2. One should note that this, whatever the operations we have did for union, intersection and the ring sum, all of them are commutative. What do you mean by commutative? That means either you can do this operation or you will do this operation. That means either you can calculate the intersection between G1 and G2, or G2 and G1, they are same. G1 union G2 if you do, or you can do the G2 union G1, it is also same. If you do the G1 ring sum G2, or you can do the G2 ring sum G1, they are the same. What will happen if G1 and G2 are edge disjoint? Then what you can say about G1 intersection G2? What should be the graph G1 intersection G2? Edge disjoint. What do you mean by disjoint? There will be no common edges there. That is known as an edge disjoint. So edge wise they are disjoint. So what will happen to G1 intersection G2? If you can see the definition of intersection, it says that those vertex and edges are common in both. If the graph does not have common edges, then what will happen? The graph is a null graph. The null graph in which there is no edge. And what is the union? What will be the union? The union is G1 direct sum G2, because into the this ring sum graph, the edges which are neither in G1 nor in G2 are common in both, but not in common in both. So there is no common edges. So whatever the edges is in G and whatever the edge in G2 will be there. So that is the things you got. There are some other property that we can mention here, that if any graph G is there, then what will be the G1 union G? G union G. That is G itself. What is G intersection G?
5. Null set.
Sir, G.
No.
G.
G itself.
G.
What is G direction with G?
Null.
Null graph. Okay. So this is the property that you can see.
Excuse me, sir.
Yes.
Sir, do we have union all?
Union all means?
Sir, in which common common lines also come two times, like in DBMS, sir.
I'm not getting what you are saying.
सर डीबीएमएस में जैसे सर है ना यूनियन ऑल जो होता है उसके अंदर सर जैसे एसआईडीज है अपनी दोनों टेबल्स के अंदर तो सर वो दो बार शो करता है यू आर नॉट गेटिंग
No.
ओके सर नो
Sir,
प्रॉब्लम
he is saying that those lines which are repeating, it will come two times.
No.
यस सर
No. See, in the union graph, we have already mentioned that. See, we have drawn this. A is repeating two times. It is in G1, also it is in G2. So we have to draw only one time. D is a edge which comes in G1 as well as in G2. So it is or. The union means or, either in one of them will work only one. So that is the definition of a graph. Now will have a deletion or decomposition of a graph. First of all, let us define what is decomposition of a graph. That means graph can be decomposed into two graphs. A graph G is said to be decomposed into two graphs G1 and G2 if G1 union G2 is G and G1 intersection G2 is null graph. Okay, so any graph can be decomposed into two graphs if it is satisfying this. Union will be a whole graph and the intersection will be a null graph. Now there is a definition of edge deletion and the vertex deletion. So let us discuss the definition of the vertex deletion. What does it mean of a vertex deletion? That means we have to delete some vertex from the graph. If V1 is a vertex in a graph G, then it is denoted as G minus V1. Denote, it is actually a subgraph of, denotes as a subgraph of G obtained, this is obtained by deleting V1 from G. A deletion of V1 means what? You have to delete all the edges which are incident to vertex V1. Deletion of a vertex V1 implies, always implies deletion, the deletion of all the edges incident on vertex E. Vertex V1. For example, let us consider this. If I have, this is the graph. Let's say this is the, a graph is there. And this is my vertex V. This is the graph G. Then what is G minus V? As per this, the vertex deletion means that you have to delete all the edges which are incident to that vertex and as well as the vertex itself. So I want to delete this vertex V1. Then the new graph, that means this has to be removed. So this has to be removed, this has to be removed, this has to be removed, this one is also removed, this one is also removed. All these edges will remove, the vertex stay. So what will be the G minus V, you will have, it is this graph. This is G minus V. So this is known as a vertex deletion. A vertex deletion means whatever the edges which are incident to the vertex B, all the edges will remove. That is called the vertex deletion. Now the next concept is of edge deletion. The edge deletion is the denoted as G minus E1 if E1 is the edge. So if the edge, if I can write, if E1 is the edge of G, graph G, then G minus E1 is a subgraph of G, obtained by deleting the edge E from G. Deleting edge E, it does not mean that you have to delete the end vertices of that. So that we should write here. Deleting edge E1 does not mean to delete the end vertices. For example, if I have a edge E here, and if I want to plot G minus E, so deleting a edge means just need to delete the edge. The all remain things remain same. So the graph will be like this. All remaining things is there. So you can see that all other vertices and all other edges will remain same. Only the edge E is removed. So that is called edge deletion. So G minus E1 is actually G direction E1 also, I can say. The next definition is called fusion of a fusion is actually a word which is used in music. So can somebody tell me what do you mean by fusion? Meaning of fusion? Mixing. So it is a something you have to mix. Okay. So here the fusion means you have to the two pair of vertices you have to fuse in between them. So that is known as a fusion. So how to do the fusion of two vertex in a graph G? So a pair of vertices A and B in a graph G are said to be fused if the two vertices become one, are replaced by a single new vertex. So what is that? There will be two vertex A and B, and that will be replaced with the new vertex, one single vertex, in such that, or such a way that every edge which are joined with A and B, they should join or incident with A and B, they all incident with a new vertex. So the every edge that was incident on either A or B or both is incident with new vertex. See, a fusion of two vertexes does not mean the number of edges will be changed. Number of edges will be same, but a number of vertices will reduce by one. For example, let us have this graph. Let's say this is the graph, and in this graph, if I denote this is as A, B, C, D, E, F, and the edges which are denoting as 1, 2, 3, 4, 5, 6, and 7. So there are 7 edges. Now we have to fuse the vertex A and vertex B. Fuse means you have to make it in one, a fusion of the two vertices. So as per the definition, it says that the two vertices will become one single vertex. So this A and B is actually become one vertex. So you can say that this is my D, this is C, here it is F, and E is there. But this A and B will become one single vertex, and I am denoting as red. So let us denote that this is D, this is C, this is F, and this one is E, and this is the vertex A and B together. Now what will happen? See this, what you have to do for the edges. So every edge that was incident on either A or B or both is incident with new vertex. So here the incident with A and B, there are many vertices are here. See, first of all, 2, 1, 3, 5, 6, they are incident with either A or B. All these vertices has to be incident with this new vertex. So what are the vertices which are not incident with A or B? That is this vertex, sorry, this edge 7. So I am just writing the 7 as it is. Now 5 is here, so just let us draw this 5 as it is. Okay, a 4 with, which is a 4 vertex which is incident with A, so that is incident with this new vertex. So this is my 5, this will be 4. 6 is there, so this is 6. Then E, which incident with A, so that will be incident with this EB. So this is not 1, it is 1. This one is 1. Now what will happen to 2? Can somebody tell me what will happen to 2?
Sir, self join.
it is a self loop. Okay, so this is the 2, and the 3 is incident with V, so that's why it is. So this is a diffusion, sorry, fusion of a 2 vertex. So this is a definition of a fusion. Hope everyone is understood. If you want, you can just try to draw a different graph and try to do the exercise by yourself. Okay, now next definition is enclosed subgraph. So enclosed subgraph, a subgraph H is an inclusive subgraph if each set of H is the each set of G, each set of H is equal to each set of G intersection with each set of vertex set of H. Okay. So this is the definition of inclusion of a graph. For example, let us see this example. So this is my graph G. We can plot a spanning subgraph of this, which is, I can say this one is a spanning subgraph of G. This is a spanning subgraph. And what is the include subgraph? As per this, it is E of each set of H is a each set of G intersection each set of vertex set of H. So this is H, if I can say. So it is intersection of edge set, whatever the edges are here. Any edge you can pick, and vertex you can pick, an intersection of this two. So I can draw this one, or many more are possible. So this is enclosed subgraph. Now the next definitions are regarding walk, tail, and path. That I think so we'll discuss in the next lecture, because it is already 10:51, and if I can do it, then it will not finish. Fine. If you have any questions regarding this, you can ask.